Hello, good morning to you all. Hello, good morning.
Morning, sir.
How about the visuals? Can you all see me? Can you
Yes,
all,
sir.
yeah, can you all hear me?
Sir.
Okay, right. Right. Today we are going to start with the topic called as measure of dispersion. Yesterday we talked about measure of central tendency. So when you measure the central tendency, we have three things that we can measure. What are the measure of central tendency? What are the measure of central tendency?
Mean, mode,
Mean, median,
mode.
and mode. Right? These are the three measure of central tendency. However, we have seen the strength and the weakness of measuring all these three right? That we have discussed yesterday lengthily. Today we are going to talk about the other type of measurements, which is called as measure of spread. Measure of spread, or we can call it as measure of dispersion. Can you tell me in Sinhala and Tamil what is dispersion? What is dispersion?
Vyapti.
I couldn't hear. Vyaptiya, right? Partially it is correct. Vyaptiya, right? In Tamil?
Parallel.
Parallel, right? So, Vyaptiya or parallel in Tamil. What do you mean by actually dispersion? Suppose, let's say we have a data of 3 people, 20, 25, 30. So we try to measure. This is one set of data. Another set of data, let's say 25, 28, 32, 45, 65. Right. Now you see, this is one set of data. This is another set of data. What do you think? Which data is spread more? Data set 1 or data set 2? Which one is spread more?
Second set.
Yeah, this is spread more. So this has been spread more compared to this. Right, now let's look at what are the measures that we are going to use to identify the spreads of any data sets. Right, there are 4 types of measures available to measure the dispersion. 4 sets of information can be used to measure the dispersion. Right, what are those? First one is the range, right? First one is range. Second one is variance. Third one is standard deviation. And fourth one is coefficient of variation. So we are going to look at each of these separately in detail. Their strength and the weakness and so on. Right? What are those? Measure of dispersions can be measured in 4 angles: range, variance, standard deviation, and coefficient of variation. Right. First one is range. First one is range. What do you mean by range? It is a simple measure of dispersion. Can somebody tell me what is range? It is the value which indicates between the highest value in the data set and the smallest value in the data set. So the data set can be given in terms of range based on their highest value and the lowest value. So highest value or the largest value or the maximum value versus the smallest or minimum or the lowest value, right? Suppose I have an example to say that a data set. Let's say I have a data set 20, 22, 28, 45, 15, 65, and 48. Can you tell me in this data range or the data set, what is the largest value and the lowest value? Largest value and the smallest value. What is the largest value?
65.
65. The smallest value?
50.
Yeah?
15.
15, right. So actually, we can give the value as a range of this data as such, or we can give this as a 40. The range of this particular data set is 40. Suppose, let's say this is a marks of 7 students, right? Marks of 7 students. So we can say in that class, let's say we have this is a A-level class, the marks of 7 students. So the range of the marks of this class is 40. So that is actually, it's indicate the dispersion. It ranges with 40 as a dispersion. So that is how we can indicate as a
50.
Sorry.
50.
Yeah.
40.
Okay, 50, right. So change it as 50. Sorry. This is 50. Right. So this range is actually indicating the difference between the largest or the highest or the maximum value versus the lowest or the smallest or the minimum value. Right. We can say this range is sensitive to outlier. Can somebody tell me why it is sensitive to outlier?
Range is described from that largest value and lowest value.
Okay. Therefore, outlier.
Outlier means the largest value in that range. So
Right. Okay.
it affects.
Right. So you are right. Outliers, because yesterday we have seen some outliers where I have given outliers in this positive direction. For example, we have seen an age in a class 20 values, then 21, 22, 23, and I couldn't remember the other value, but the largest value is 65. I think yesterday example in that table. So you see here, this is an outlier. This is an outlier because it is not behaving in a similar pattern of the group of data. So this is behaving totally different, right? One more thing, because this outlier, just now somebody is answered the outliers usually the larger values. It is not necessary as such, right? Let's say I have marks of 7 students, right? Right. Now This is my data. Tell me which is the outlier.
10.
10. So the outlier mean it can be a lowest value or it can be a highest value. Doesn't matter. But the principle is that value not adhering to the rest of the value. So the rest of the value is coming as one group. This is coming as another group. So this 10 is an outlier here, but it is the lower value, isn't it? So you can have higher value or lower value. Doesn't matter in this case. In the range, we are talking about the largest value and the smallest value. Whatever the way, whether it is a positive outlier or negative outlier, will influence the value of the range. Therefore, we could say this is sensitive to outlier, right? Is it clear? The range is sensitive to outlier. Right. Now let's look at any questions on range. Right. Now let's move to the variance. Variance. Let's move to the variance. Variance. Can somebody tell me what are the words in Tamil and Sinhala? Variance. Difficult to get the actual technical term. We will see for a data set what is meant by the variance, right? So the variance, right, is defined as it measures the average squared distance that score deviate from their mean, right? We will come to that in detail. So it is indicating it measures the average deviations, right? Some of the key terms, deviation from their mean. So these 4 keywords are very important. It is measuring the deviation from their mean. After that, it has been squared. So these are some of the keywords here. Variance, we can calculate in different ways. This variance can be said as 2 types of variance. Can you remember when we talked about mean? What type of means are there?
Arithmetic mean.
No, I mean those are different types of means. But when you talk about means in terms of 2 aspects, parameter and the estimate.
Population mean.
Yeah, this is population mean.
And
This is
sample
sample
mean.
mean. Yeah. So those what you said, the arithmetic and other types of mean, that is different types of means. So here, this is the means depend on what population are we talking about, whether we are talking in terms of population or whether we are talking in terms of sample, right? Right. Similarly, here also the variance can have 2 types. One variance is this is called as sample variance. Right? The other one, this notation is called as population variance. This is called as sample variance. This is called as population variance. So how we denote sample variance? By S square. The population variance, we denote it by, this is called as sigma square, right? Hereafter, if I write sigma square, it indicates the population variance. If I write S square, that indicates the sample variance, right? Similar to that, in this case, this is the population parameter, which we estimate through sample. So these are the population parameter. These are the estimate from the sample. Right. Now, shall I clear this? What I have written? Population sample and the population variance and sample variance. Right. One more thing here. Outliers. Okay. So this is the variance are actually sensitive to outliers, similar to the range. Variance also sensitive to outlier. So actually, variance, I'm going to show you how variance could be calculated, right? How variance could be calculated. How variance could be calculated. Let's say I have a data. I will take a simple one. 5, 6, 7, 8, 9, 10. I have a data. So can you tell me what is the mean of this? Can somebody calculate and tell me what is the mean of this? Yeah.
7.5.
Yeah, 7.5. We need this value, that's why I am taking this value. So the mean is 7.5. Right. Now, for example, for this data, right, 5 minus 7.5. 5 minus 7.5 plus for this data 6 minus 7.5. So likewise, what about the next one? Plus
7 minus 7. 7 minus
7.5. Good. 7 minus 7.5. So likewise, you add all the deviations. These are deviations, right? Divided by. So you add the deviation divided by. We will come to that later. N minus 1. This n is already, you can recall what it is, right? N, you can recall it is the sample size or the sample number minus 1, right? Plus, you can complete the rest, right? Now, you see, what about this value? I will put this also, 8 minus 7.5. Right? Can you tell me what is, whether it is a positive or negative value? 5 minus 7.5, is it a positive or negative?
Negative.
Negative. This is a negative value, right? What about this?
Negative.
Negative value. What about this?
Negative.
Negative value. What about this?
Positive.
Positive value. The rest also positive value. You see, when you have plus sign here, adding sign here, this negative and positive will be cancelled off. Plus and minus will cancel off, isn't it? Ultimately, you end up with 0. You calculate and see, it will end up with 0. So actually, we want to measure the variance, but we end up with the value 0. That will not reflect actually the variance. Therefore, what we can do to avoid, because I write it here, 5 minus 7.5. So this is the first data. So this become as minus value. So to get rid of this pluses and minus, what we can do? We can
Squat.
square, right? Okay, we can square, right? So once you square it, then automatically all the minuses will become as plus and all the pluses become as minus, right? So that we will continue with the same thing again on the other slide with an example, right? Right, this is the formula that we come across. This is the formula in general that we come across to calculate the variance. You see here, this is the format that I have already written to you with an example. This is each observation minus, there will be only one mean value for a given data set, right? What do you mean by summation? It is adding each and every observation in the data of the deviation. Then you have the square, right? You have the square divided by n minus 1. So these two components have different names. Sorry. What is that? This component. How do you call? How do you call that component? Sums of squares. We call that component as sums of squares, right? So hereafter you will talk about this sums of square very oftenly. I will explain this later. This is called as degrees of
freedom.
Degrees of freedom, right? Sums of squares divided by degrees of freedom. That is actually called as variance. So what type of variance are we talking about here? S square means
Sample variance. Sample variance.
sample variance. Yes, we are talking about sample variance. So if it is a population variance, I'm not sure whether we have that here. Otherwise, no. Just a second. We'll write the population variance. I will explain the difference between population variance and sample variance. Population variance is given as summation xi minus, what is the mean? How do we write population mean? Mu square divided by capital N. So this is how we write the population variance. What is the difference here? Two differences are there. What are those differences? here we are talking about population mean. In this case, it is population sample mean. So that is first difference. What about degrees of freedom here? What are the degrees of freedom here? Yeah? Anyone? What is the degrees of freedom there? Anyone? N is the degrees of freedom. So when you have a population size, usually it is very big. Suppose let's say my N is 10,000. My N, capital N is 10,000. Suppose if I am going to divide the sums of square by N, capital N, right? So I'm dividing this by 10,000. If it is N minus 1, what is the value? If it is N minus 1, according to this, capital N minus 1, what is that? 9,999. Is it 9,999? Can somebody tell me this is actually N minus 1? If you divide a component by 10,000 or divide by 9,999, will it make a huge difference for the yeah. Right? Will it make a huge difference whether you divide by 10,000 or whether you divide by 9,999?
No.
Will it make a huge difference? No. That is why the population usually is a larger value. Usually population is larger value. So this degrees of freedom, which is N minus 1, will not work to the population. Whether you are dividing, let's say I am dividing 50 by 10,000. Right? 50 by 9,999. So does it make huge difference between these two? Yes or no? Somebody already
No.
said
No.
If you put it in calculator and see, the difference is more or less same. So this is more or less same. So that is why we consider for the population variance degrees of freedom as N, not N minus 1. Right. I want to talk about little on this degrees of freedom, what it is. Right. I'm clearing. I hope you have already taken down the notes. What is this degrees of freedom? What is this degrees of freedom? Can somebody tell me? Right. Now let's say I have 10 balls. I have 10 balls, different colors here. I will put it in different colors, right? One is a red ball. The other one is a yellow color ball. So likewise, you have different colors, huh? Right? Right. For the time being, that color is enough. So how many balls are there in the box? How many balls are there?
10 balls.
10
Four.
balls are there. Now, by closing my eyes, I'm going to take one ball out from the box. Right? What is the chance of selecting the red ball? So assume we have only one ball for each color. Let's say I'm saying red color. What is the chance of selecting the red ball?
1/10.
1 over 10. Yes, good. Because we have totally 10 balls are there. Because red color, there is only one red color ball inside the box. So 1 over 10. So I have taken the red color ball out. Right. Now I'm going to take the, how many balls are there now?
9.
9. So now I'm going to take the next ball. Let's say, what is the chance of selecting one ball out of this 9?
1 over
1 out of
9.
9.
1 over 9. Right. Okay, good. So likewise, I have already taken the second ball. Then again, third ball. What is the probability of selecting the third ball? One color will be selected as the third ball. 1 over
8.
Isn't it? So likewise, everything is gone. Now all the balls have gone. Now I have only 2 balls left. Now I have only 2 balls left. Now, what is the probability a ball will be selected out of these 2?
1 over 2.
1 over 2. Fine, good. Now that ball also have been selected. Now how many balls are there inside the box?
1.
1. Now what is the probability selecting the remaining ball?
1.
1. You see, what about this last ball? Is it independent or dependent?
Independent.
Once again,
Independent.
no. Is there any other chance to select another ball? Or we must select the same ball?
Same.
Is it independent or dependent?
Independent.
Once again, why? Because if you put the hand into the box, how many balls remaining now? Only one ball is remaining. So some or other, you'll have to take the same ball. No other choice. So this ball is dependent or independent? Dependent. Isn't it? It's called as dependent. Not independent, it is dependent. Why? In earlier case, you had enough balls to select one of those. But now, at last, you have only one ball. No other choice. You'll have to select the same ball. Do you understand? So you'll have to select the last ball, some or other, no other choice. So it is dependent. So usually when you have sample is a small size. In the sample, the last observation is always dependent. Therefore, we take out the last observation for the calculation, which is called as degrees of, simply we put it as df. Hereafter, if I put it as df, that is degrees of freedom. So do you know the reason why degrees of freedom is 1 minus 9? N minus 1? Right? Now let's say my n is normally sample, which is very small. Suppose n is 10. What is n minus 1? 9. So suppose if I am dividing 50 by n, which is 10, again this 50 by n minus 1. Can we say these two are equal? Like as we said earlier?
Can't.
We can't. Why? Because this 50 minus 9 will have a slightly more value than 50 divided by 10. So that this is not equal. So that is why we write the degrees of freedom for sample as n minus 1. Sample degrees of freedom is always n minus 1. For the population, whether you have n or capital N or capital N minus 1, will not make any much influence because that value is very, very large, right? Further, this sums of square can be elaborated as such, right? Sums of square can be elaborated as such. I will clear that. So sums of square of those can be elaborated thus. What do you mean by x square? Summation of x square mean, let's say this is a value x square, let's say 2, 4, 6. I will take only 3 data. What is x square? 4, 16 and 36. If you add this value, it is giving us summation x. What is summation x? This is 12. What is summation? If you add all these x square, this is giving us summation x square. So what is the value?
56.
56. So you see, we can simply substitute the values. So I will substitute the value here to find out. First one is summation x square. What is summation x square? 56 minus summation x whole thing square. All right. Summation x we know that is 12 whole thing square divided by n. What is n here in our example? 3 whole thing divided by n minus 1, which is 2. So this is my sample variance. This is my sample variance of a data of these 3. Is it clear? Is it clear? Right, that is the sample variance. So this is a simple calculation. So you can make a note of it. Huh? Right, I will clear. Then we will go further on this variance. Just description about the variance. You can read variance of a random variable. We'll define the term later what it is, a random variable. Sorry. We can define the term random variable probably next time, not sure. Random variable. Variable we know. Variable we know. We define the term variable. Random variable mean the value of that variable can, any value of that variable can occur. They have a chance to occur any value of the variable. It is called as random variable. We will see that later, right? Or distribution. Distribution mean, for example, this is frequency. This is classes. What type of classes? Maybe this is, if you draw simply the bar charts or whatever it is frequency. If you connect all the middle point, so this is called as distributions, right? Is the expectation or mean of the square deviation. That is what we have already talked about, right? Mean, I mean deviation with the mean, then you square it up of that variable from its expected value or the mean value. So that is expected value mean, it is the x bar. Thus the variance is a measure of the amount of variation within the values of that variable, taking account of all the possible values and their probabilities, right? We'll talk about in detail, right? So that is how we can calculate the variance. Okay, I have already a typed example. I have numbers 5, 10, 7, 8, 15. Can somebody find the x bar, the mean value of that? and tell me. It is already there, maybe. What is the mean value?
Nine.
9. 9.5. Huh? Madhusha, what is the value?
9, sir.
9. Okay, fine, good. Now we can calculate the variance as we did earlier, right? The first observation is 5. So that 5, right? First observation is 5. So 5, sorry, 5 minus the mean value, right? 5 minus the mean value, then you square it up. 10 minus the mean value, square it up. 7 minus mean value, square it up. 8 minus mean, 15 minus mean, and square it up. You get the 58. How do you call this 58? Can you remember? I said something. How do you call this term? I said the summation xi minus x bar whole thing square divided by n minus 1. Yeah, Pavidarani?
Sum of squares.
Exactly, sums of square. This component is called as sums of square. Usually in statistics we write SS. If you see SS, it is sums of square, right? Sums of square has been calculated. Now we need to calculate the second one, degrees of freedom. What is degrees of freedom? In our example, what is the total number of observation?
5 minus
5. So 5 minus 1, which is 4. So sums of square, which is 58, divided by 4, which is the degrees of freedom. So our value is 14.5. So that is the variance that we have. Right? Clear? So this we can expand it in a simple format. I have already done. We can do it in a different way because you see, if you have a larger data set, doing by this way is a little bit hassle and takes more time doing by this way. So you'll have to square it up separately, the differences, then you will have to add. Nowadays the programs are available. However, the easy way is using this formula. So you see that x variable, they are squares, you add the values, right? This is summation x, which is 45, and summation x square, which is 463. So we can use that for the calculation. So in simple, you will get the same answer. If you don't get the same answer, something wrong somewhere, right? So this value should be equal to this, this value, right? Whatever the way, this is one way that we can calculate the variance. This is another way that we can calculate the variance. Suppose, let's say, if you don't square it, what will be the answer? If you don't square it, what is the answer here?
0.
Huh?
0.
0, yeah, exactly. It is 0. So we try to measure the variance, but ultimately we end up 0 here. Therefore, that's why we are squaring each and every observation, right? So, right, let's move to the other part, the fourth category. It's called as standard deviation. Third category, standard deviation. Actually, standard deviation, nothing other than standard deviation is actually it is given as S. S mean what sort of standard deviation? What standard deviation is that? This is sample standard deviation. I will put it as SD. Sample standard deviation. So how we write population standard deviation? As such. So that is equal square root of sigma square. Square root of sigma square. It is simple term. Standard deviation is taking the square root. Why we take the standard deviation? Actually, if you look at the variance, we said 14.5. In early example, the variance is 14.5. Can we elaborate this? Let's say we have the unit centimeter. So let's say this x unit having in centimeter, right? X unit is having in centimeter. So that now how I can put the unit here, because this is square. So I can put
Square centimeter.
square centimeter square, right? So this is my unit. How we can explain this? Explaining this is a bit difficult. Why? We have already what we have done, the deviation that we have already squared out. So we cannot talk about much of the deviation since we have squared it out. So that the variance is not an actual way that we can explain a data. So the best is standard deviation. Standard deviation, right? That is the best one that we can explain. Standard deviation is after taking the square root, right? We are taking the square root because we are squaring it up, then we are taking the square root. We are taking the square root, isn't it? So after taking the square root, it is coming to the normal form. For example, if you take the square root, can somebody use the calculator and let me know the value?
3.8.
No, take the square root of this. 3.8, right? Once again, what is the value? 3.8.
3.8.
What is the unit now?
Centimeter.
Centimeter, because it is already square root has been taken out. So now it is centimeter. Now we can explain this. So we can explain this. How we can explain? You can write down on an average. Write down. I cannot write the whole thing. Write down. On an average. On an average, the given data set. The given data set on an average. Given data set means the earlier data set that we have discussed. On an average, deviation. Deviating 3.8 centimeter on an average. The data set is deviating 3.8 centimeter from the mean value of the data set. From the mean value of data. On an average, it is the deviation from how much they are deviating from the mean value. It can be positive or negative, doesn't matter, right? How much they are deviating from the mean value. So that is how we indicate the deviation. Right. You don't need to worry about much about the explanation. We will discuss that in detail of the deviation. However, keep in mind how we can define the deviation, right? So this is the standard deviation. The last one, I think we can finish this also and then complete the class, right? The last this question is coefficient of variation. This coefficient of variation is basically indicated as CV, not the CV that you are talking about curriculum vitae, right? So this CV in statistics is called as coefficient of variation. This coefficient of variation is given as S divided by X bar. What is S?
Standard deviation.
Standard deviation, fine. Sample standard deviation, right? That is S. What is this? X bar? Mean. What mean?
Sample mean.
Sample
mean.
mean. Right? Sample mean. Are you all sleepy? The answer is like a drowsy smell. Huh? Sample mean. What is that? So you'll have to say correctly and conformly that it is sample mean. Right. So this is the relationship between the variance. Actually, it is standard deviation divided by the mean, which is called as the coefficient of variation. Right. Now I have an example. I have an example. I am taking two. You don't understand what is this? Huh? I have two animals. I have taken two animals, right? One is elephant. You mean elephant, right? Elephant. A mean, what is the smallest animal? Ant. I have taken this ant and the elephant, right? So this is the information about the elephant. This is the information about the whom? Huh? Information about the ant. Not auntie, this is ant. You know ant? What is the meaning of ant? Anyone? What is the meaning of ant? A-N-T?
Insect.
Right, insect, right. In Tamil, Rumbo, in Sinhala it is Kumbi, right? So we are talking about the ant, not auntie, and the elephant. Right. Now, can you tell me where do you get the coefficient of variation in general? Whether it is in elephant by looking at their features, or whether it is the coefficient of variation is in ant. Guess. Normally, if we ask that question, we might see by looking at the elephant, because it is big enough, we might think that the coefficient of variation is high in elephant compared to the ant. But we are going to do some calculation and see whether that statement is correct or wrong. Right, this is the elephant information. Their standard deviation is 0.4 ton because they have been measured. Their weight and the mean is 8.8 ton of the elephant that has been measured. Similarly, the standard deviation of ant is 0.005 kilogram in kilogram. As an example, the mean is mean of ants that has been measured is 0.0009 kilogram. So now if you calculate their respective coefficient of variation, you will end up with some values like this. So where the coefficient is higher, which animal has coefficient, higher coefficient? Yeah,
And
ant. Why? Because in ant also there's a huge variation in ant compared to their mean value. Compared to their mean value. So here the mean value is higher compared to their variation. So that is the difference. Compared to their variation, their mean value is higher. Here, compared to the variation, the mean value is much smaller in ants. So you see, ant has a coefficient of variation 555, whereas the elephant's coefficient of variation is 50. So that is how we can indicate this coefficient. When you come to your final year research, you will be using this coefficient of variation very much, especially if you are doing research in animal science or agronomy. You may come across with this different way of interpreting this coefficient of variation. Right, I think I will stop here. Anything to be discussed? Any questions? Jeffrey, are you around?
Yes, sir.
Okay, right. How about our next class? This week, no class. Next week,
Sir.
I think most probably Tuesday, I will be taking.
Tuesday. Okay, sir.
Tuesday, normal time.
One more time. 1 to 3.
1 to 3. If there is any changes, I will let you know. But Tuesday,
Okay, sir.
1 to 3. So any other questions? Anybody would like to ask questions? You can type the questions even under the what do you call chat also, where I can entertain the questions if you have some. Yeah. Any questions? Yes, Arosha.
So why you told that during the degree of freedom one, you told that last observation is dependent, no?
Yeah.
But it is independent because I think I don't know. In the first ones we conclude our observation from that depending other observations, like 10 balls we depend on other 10. Why you told that?
No, thing is, when you have 10 balls, we have chance of getting any colors at the beginning, right? So the choice is independent. Do you understand? The choice. Arosha, are you hearing?
Yes.
Yeah, the choice is independent. For example, there are 10 balls inside the box. Now, because all 10 balls are different colors, let's assume all the 10 balls are different colors. So when I take the first ball, that first ball is totally independent on other balls, because any ball out of this 10 can be selected. So all the balls are independent. So likewise, if you go on, at last, there will be only one ball remaining in the box. So that ball has independent or dependency. Are you Tamil or Sinhala? Sinhala. Then box එක ඇතුලේ එක බෝලයයි තියෙන්නේ අන්තිමට ඉතුරු වෙලා. තේරෙනවද? එක බෝලයයි තියෙන්නේ. දැන් ඔයා කොහොම හරි box එකකින් බෝලය ගන්න ඕනේ එළියට. එක බෝලයක් ගන්න ඕනේ. එතකොට ඔයාට වෙන choice තියෙනවද?
Yes.
අන්තිම බෝලේ අනිවාර්යයෙන්ම ගන්න වෙනවානේ.
ඔව්.
අන්තිම වෙන choice එකක් නැහැනේ. එතකොට අන්තිම එක dependent. අන්තිම බෝල එක dependent. ඔයාට වෙන choice එකක් නැහැ because ඒ box එකේ එක ball එකයි තියෙන්නේ. ball ගොඩක් තියෙනවා නම් choice එකක් තියෙනවා වෙන ball එකක් ගන්න. but මෙතන වෙන choice එකක් නැහැ. No other choice. So you are forced to take the last ball which is in the box. අරෝෂා තේරුණාද?
ඔව් සර්.
ඒ නිසා තමයි ඒක dependent කියලා කියන්නේ. දැන් අපිට ball එක ගන්න ඕනේ එළියට. අපි sample ගන්න ඕනේ එළියට. නමුත් එකයි ඉතුරු වෙලා තියෙන්නේ. ඒ ඉතුරු වෙලා තියෙන එකට choice එකක් නැහැ. අනිවාර්යයෙන්ම ගන්න ඕනේ.
Thank you, sir.
Right? Okay. Any other questions? If not, we can close it up. Right? Okay. See you next week. Okay. Bye.